Hello everyone, welcome to my YouTube channel. In today's session, we are going to discuss about a very important paper, which is paper 62, alternate to practical, February March 2024. This paper is very important, and the students were going to for the final CIE in May June 2024. They should solve this paper. So let's start from the question number one. This question is that calcium carbonate is an insoluble solid, and calcium carbonate can be made by adding excess aqueous calcium chloride to the aqueous sodium carbonate. So the aqueous calcium chloride is in excess. So this is the reaction between calcium chloride and sodium carbonate, and this is a precipitation reaction in which we are getting the calcium carbonate insoluble solid. The idea is already in the question. A student makes a sample of the calcium carbonate, and the first two steps of the method are shown in this figure. So this is the step one in which aqueous calcium chloride and aqueous sodium carbonate, they are being mixed, and we're using the excess aqueous calcium chloride to aqueous sodium carbonate, and in step two, stir the mixture. Let's start from the questions that name the item of the apparatus labeled in A. As you can see that the item which is used to stir the mixture is the stirring rod, or you can see the glass rod. So this is stirring rod. Or you can also see this is the glass rod, which is used to mix the two solutions. So just why the mixture is stirred in step two. Definitely, the purpose of the stirring rod is to mix to mix the reagents together. Or we can see that this can also be used to increase the rate of reaction. Without mixing, this reaction may take some more time. After step two, the student filters the mixture to remove the solid calcium carbonate formed and collect the filtrate. Draw a label diagram to show the apparatus used for this filtration. There is a specific apparatus which is used for the filtration. So you must have a flask or any receiving container. Then you can use the filter funnel. And don't forget to draw the filter paper. So this is filter funnel. This is conical flask. And this is filter paper. So the residue of calcium carbonate that can be collected here, and the filtrate here. So this is the residue. And the aqueous solutions in the form of filtrate. So this is the diagram of process filtration. The solid calcium carbonate obtained by filtrate is not pure. Identify one substance other than the water, which is mixed with the calcium carbonate and makes it impure. Just look at the statements at the start of this question. We're using the aqueous calcium chloride. So this calcium chloride is in excess. So we can identify the limiting reagent, so that this is limiting reagent. And limiting reagent is the reagent which is consumed earlier or consumed completely. So there will be no impurity of sodium carbonate at the end of the reaction. So we can't write the name of the sodium carbonate. This is the precipitate, so we may get the precipitate on as a residue on the filter paper. Because the calcium chloride is in excess, so the impurities of calcium chloride may be there, or we are getting another aqueous product as well, sodium chloride. So the substance other than the water, because this is a aqueous, so water is also there. So other than the water, sodium chloride or calcium chloride may be there. You can't write the name of the sodium carbonate because sodium carbonate is a limiting reagent and it is used completely. So identify one substance other than the water which is mixed with the calcium carbonate and makes it impure. You may write the calcium chloride. This is used in Axis, and one of the product which is formed along with the calcium carbonate, so sodium chloride. Describe how the substance you have identified in D1 can be removed from the calcium carbonate. So calcium carbonate is obtained at the filter paper. So here you have the calcium carbonate, because calcium carbonate is an insoluble salt. So it may have some impurities of the two reagents we have already talked about, that the calcium chloride or sodium chloride. So to remove the impurities of the soluble salt, the distilled water can be used. So if we wash the precipitate with the distilled water, so we can remove the soluble impurities from the calcium carbonate as a filtrate, and the filtrate become the part of the flask. So what will be done? Add distilled water on residue to remove the traces of soluble salts. Describe a test the student can do on the filtrate obtained in C to show that the calcium chloride used in Axis. So our filtrate contains the different substances, like it contains the calcium chloride, the cation and aniline, and sodium chloride. Now, to show that the calcium chloride used in Axis gave the result the student obtained if the calcium chloride is in Axis. So to test the presence of calcium ions, we can use the aqueous sodium hydroxide. The informations are in this paper as well, that how can we do the test for calcium ion. You can use page 14, not 14, 15. Here you can see the calcium ions. Yes, here the calcium ions are here. So to test the presence of calcium ion, uh, aqueous sodium hydroxide is used, and white precipitate, and insoluble in excess. So you can use the aqueous solution of calcium hydroxide. This information is already in the paper, so you can use the last 3 pages for the test for cations, anions, and gases. So the answer is that use aqueous solution of sodium hydroxide. So if we add aqueous solution of sodium hydroxide, the results white precipitate. Because by adding the aqueous solution of sodium hydroxide, the cation like Na positive, that will not give us any information or any observation. So that's why if the only sodium chloride is the part of our impurity, we will not get the white precipitate. So this proves that the calcium chloride is there. So that's why the calcium is producing the white precipitate with aqueous sodium hydroxide. Now, the white precipitate, we can get the white precipitate through filtration. So if we filter, we'll get the precipitate. So uh, calcium chloride used it in access. So give the result the student obtains if the calcium chloride is in access. So these white precipitate, they can be obtained through filtration. Again, if we do the filtration, so filter to get uh, calcium uh, hydroxide as a residue. Because we're adding the sodium hydroxide in calcium ion. So this is calcium ion and sodium hydroxide, the precipitates of calcium hydroxide. So these are the precipitates of calcium hydroxide. Then this is another question. A student investigates the reaction between aqueous sodium carbonate and the two different solutions of dilute hydrochloric acid labeled A and B. The student does three experiments. This is the experiment one, then two, and then three. So there's a lot of information. So you can pause the video and look at the informations which are regarding question, experiment one, two, and three. And then I will let you know the answers. Now in experiment one and experiment two, dilute hydrochloric acid is taken. So if we add the dilute hydrochloric acid in experiment one and dilute hydrochloric acid in experiment two, and in experiment three, we're using dilute hydrochloric acid, but this is experiment B. So in experiment three, the dilute hydrochloric acid B is used, whereas in experiment one and two, the dilute hydrochloric acid A is used, and the conical flask contains 25 centimeter cube of aqueous sodium carbonate. Now, and we're using the different indicators as well in experiment one and two. Now, these are the purity readings. So uh, we have to complete the purity reading. First of all, look at this reading that this is 0 and this is 1. So this is 0 0.12 and then 5 and then 6, 7 and then 8 and this is 9 and this is 1.0. So this reading is 0 0.8. This is 25 and then 26 and then 27. So the reading is increasing. So this is 25 and this is 27. So this number is 26.1 and this is 26.2. So this is 26.2. For the colorless substances, you have to take the lower meniscus. If you have a colorless substance, because here we are taking the hydrochloric acid aqueous solution, and this is colorless. So just look at the lower meniscus. If you have a meniscus like this, just take the lower meniscus. For the colored substances, you can take the upper meniscus. In experiment 2, the period readings are, this is 0 and this is 0 0.1 and then 0 0.2. So this is 0 0.2 and the final reading is this is 12 and then 12.5, 6, 7, 8, 9 and this is then 13.0. So this is 12.9. In experiment 3, this is exactly 1.0 and in experiment 3, the final reading is this is 39 and this is 39.1 because this is 39, this is 40. So 39.1. So you can complete the table by using these readings. So final period reading, be careful. You have the final period reading in the first line and then initial and then volume of the dilute hydrochloric acid or a titrate used. Take the difference of these two readings. So let me complete this table. This is 26.9. This is 0 0.8. This is 12.9 and 0 0.2. 39.1 and this is 1.0. So just subtract these numbers. So 25.4 and then 12.7 and then 38.1. So these are the final readings. These two experiments are with A, and this experiment is with B. Both are HCl. Experiment A and B, dilute hydrochloric acid is taken. Okay, so let's move to the next part. State which solution of the dilute hydrochloric acid, A or B, is the more concentrated. Explain your answer. If we look at the volumes of the A and B, as we can observe that for experiment 1 and 2 and experiment 3, this is B, this is A. You can compare the volume either with 25.4 or 12.7. As you can see that for the experiment A, 12.7 volume is required, and for experiment 3, 38.1 centimeter cube are required. This is actually for sodium carbonate, that if we titrate the 25 centimeter cube of sodium carbonate for A, 12.7 centimeter cube of hydrochloric acid is required to neutralize completely or to react completely with 25 centimeter cube of sodium carbonate. But in experiment B, the 38.1 centimeter cube is required. Okay, so to titrate 25 in experiment A, only 12.7 centimeter cube volume is required. And for to titrate 25 centimeter cube of sodium carbonate in experiment B, 38.1 centimeter cube of hydrochloric acid is required. So if we compare these volume of A and B, as we can see that the volume of A in experiment 1, which is needed to neutralize 25 centimeter cube of aqueous solution of sodium carbonate, is lower than the B. This is lower than the B. It means that A is more concentrated. Why? Because it requires there is a less volume required to neutralize 25 centimeter cube of sodium carbonate. So we can say that the more concentrated solution of the hydrochloric acid is A. It contains more particles of hydrogen ion. So what is the explanation? You can compare the volumes, because the volume of A in experiment 1 or you can say experiment 2, we can compare with the 25.4 as well. So experiment 1 or experiment 2 needed is lower. Lower than the B. It means that the B is a dilute as compared to A. So that's why it requires more volume to neutralize 25 centimeter cube of aqueous sodium carbonate. Now, the next thing is that deduce how many times more concentrated this solution of the dilute hydrochloric acid is than the other solution of dilute hydrochloric acid. So for this, we know that the 38.1 is required. For this, you have either 12.7 or you required 25. So if we compare with this, we can see that the 38.1 divided by 25.4. So this is almost 1.5 times. So this is 1.5 times more concentrated. Okay. Now, the next part is compare the volumes of dilute hydrochloric acid used in experiment 1 to the volume of dilute hydrochloric acid used in experiment 2. So if we compare the volume which is used in experiment A, experiment 1, then the volume of the hydrochloric acid used in experiment 2. So experiment 1 and 2, in both these experiments, the HCl is used, and both these experiments are A. So the let's look at the volume. These two volumes are 25.4 and 12.7. So if we compare these two volumes, we can say that 25.4 divided by 12.7, 2. So this volume is 2 times. The volume which is used in experiment 1 is the twice as compared to the volume which is used in experiment 2. So volume of HCl used in experiment 1 is twice as compared to volume in experiment 2. Deduce the volume of dilute hydrochloric acid required to reach the endpoint if experiment 3 is repeated using a different indicator instead of methyl orange. So use your answer to C1. Now in C1, the volume is 2 times. So if we compare the experiment 1 and 3, in experiment 1, the aqueous solution of sodium carbonate is titrated against HCl. So the volume which was taken for aqueous solution of sodium carbonate, that was 25. So to neutralize 25.0 centimeter cube of aqueous solution of sodium carbonate in experiment 1, 25.4 centimeter cube of dilute hydrochloric acid was required. Now, in experiment 2, if we use 12.7, because in experiment 2, the 12.7 was required to neutralize 25 centimeter cube of this. So if we compare that how much volume will be required for the complete reaction, so this is 25.0 times 12.7 over 25.4. So this volume would be 12.5 centimeter cube of sodium carbonate. So 12.5 centimeter cube of sodium carbonate will be required to neutralize 12.7 centimeter cube of hydrochloric acid. Now, if we compare with the B, sodium carbonate with HCl for experiment 3, so 25.0 was neutralized by 38.1. So if we have 12.5, then so we'll get the answer 19.05. So the volume of dilute hydrochloric acid B should be 19.05 according to the same ratio. Or if we use the same ratio, so we'll get a 19.05. So to react completely with 12.5 centimeter cube aqueous solution of sodium carbonate, so the volume of dilute hydrochloric acid required to reach the endpoint, that is 19.05. Then at the start of the experiment 3, the burette was rinsed with dilute distilled water and then with dilute hydrochloric acid B. Identify the substance removed from the burette when it is rinsed with distilled water at the start of the experiment 3. So before going for experiment 3, the hydrochloric acid was taken in experiment 1 and 2. So that's why if you want to remove the traces of dilute hydrochloric acid, we'll have to rinse with water, because in experiment 1, 2, and 3, the acid have different concentrations. So to remove the dilute HCl. Describe how the result of the titration would change if the burette was not rinsed with dilute hydrochloric acid uh, mm, B after it had been rinsed with water. So if we do not rinse with the dilute dilute water or the distilled water, what will happen? More volume of the acid would be added. So more volume of acid would be required or needed to neutralize. Then explain why the conical flask is not rinsed with aqueous sodium carbonate after it is rinsed with water. So conical flasks actually do not have any graduations. So if we rinse with water, what will happen? Why the conical flask not rinsed with aqueous sodium carbonate after it is rinsed with water? Okay, it is rinsed with water. So if we rinse with the sodium carbonate, what will happen? Actually, we're adding some more volume of sodium carbonate. We have to add 25 centimeter cube of sodium carbonate. So if some amount of the sodium carbonate is already present there, what will happen? That will increase the volume of the aqueous solution of sodium carbonate. So that actually increases the volume of aqueous solution of sodium carbonate, and the volume which is required, volume of the HCl or tighter, would also increase. Because instead of taking 25 centimeter cube of aqueous sodium carbonate, if we have 26 centimeter, definitely the volume will increase, because we have studied that for 25 centimeter cube aqueous solution of sodium carbonate, we have to require 25.4 in one experiment, and in experiment 2, 12.7, and in experiment 3, 19.05. So that's why if we add some more amount of the sodium carbonate, the volume would increase. Explain why a white tile is used during the titration. The white tile is used to see the color change accurately, to observe color change accurately. Describe the effect on the result of warming the aqueous sodium carbonate used in experiment 1 before carrying out the titration. Explain your answer. If we look at the result, because we're just changing the temperature, we're just changing the temperature only. There is a change in temperature, change in temperature. There's no change in the volumes, there is no change in the concentration. So the results are the volumes we are getting to neutralize the 25 centimeter cube of aqueous solution of sodium carbonate. Although the rate of the reaction increases, but results would remain the same. Results will remain the same. Only time, only time decreases. The reaction become fast. Why the results would remain the same? Because the concentration of the sodium carbonate does not change. Concentration of aqueous sodium carbonate does not change, so the volume will remain the same. This is regarding the titration question. Now let's move to the next question. This is for the test for cations and anions. So if you want to do the this question, test for cations, anions, and gases, you can use this paper, because the informations about the test for the cations, anions, and gases, they are already in this paper. As you can see on the page 15, notes were used in a qualitative analysis. Okay, so the qualitative analysis notes are already there, so you can use these notes if you want to test the presence of anions, carbonate, chloride, bromide, iodide, nitrate, sulfate, sulfite. So you can use these informations. This is the test and this is the result or observation. Then test for aqueous cation. So these are the aqueous cations. So they can be tested either by using the aqueous solution of sodium hydroxide or aqueous ammonia. Then you have another information test for gases as well. So these the gases. Okay, then test for some metal ions like flame test for Li positive, sodium, then potassium, calcium, barium, and copper. So these are the flame color. So you can use these qualitative analysis notes for the explanation and observation and the reagents for cations, anions, gases, and then flame test. Now look at this part. Test on solid C. Solid C is ammonium chloride. So this is ammonium chloride. Ammonium is positive and this is negative. Now here we are taking the solid, but I'm talking about the formula. Ammonium chloride NH4Cl. Ammonium is cation and chloride is anion. The student dissolved solid C in water to form solution C. The student divided the solution C into three approximately equal portions, complete the expected observation. So this solid was dissolved in the water to get aqueous solution of ammonium chloride. Now we have three different test tubes, and there are the three different tests. Now, to the first portion of the solution C, the student adds about 1 centimeter cube of dilute nitric acid, followed by a few drops of aqueous barium chloride. So, if we look at these two reagents, that barium nitrate, especially barium nitrate or barium chloride, we can also use the barium chloride as well. And now, look at the now we have two ions. One is NH4 positive and second is Cl negative. So if we look at our qualitative analysis notes, just to concentrate on NH4 positive and Cl negative. So this is NH4 positive. So the presence of NH4 positive can be tested by using aqueous solution of sodium hydroxide or aqueous solution of ammonia. Generally, the aqueous solution of sodium hydroxide will give the positive test. Ammonia produce on warming. So it means that this test is not the test for NH4 positive because he's not using the aqueous solution of sodium hydroxide. He's using the aqueous barium nitrate. Now, if we look at the test for chloride, as you can see the test for anion as well. This is the test for chloride. Acidify with dilute nitric acid, then add aqueous silver nitrate, but we are adding barium nitrate. So barium nitrate is here, barium nitrate. So barium nitrate is used to test for the presence of sulfate ion. But the aqueous solution of ammonium chloride, this is the aqueous solution of ammonium chloride, so no sulfate is present there. This barium nitrate is used for the test of sulfate ion. Because no sulfate ions are there, so we can say there is no observation, so no change. To the second portion of the C, the student adds about 1 centimeter cube of dilute nitric acid, followed by a few drops of aqueous silver nitrate. So this test is used for the presence of chloride ion. You can see the qualitative analysis notes. Always use these notes. Acidify with the nitric acid, then add aqueous silver nitrate, and you have to write down the observation. And then okay, so this okay. Oh, sorry. This is iodide. Yes, this is iodide. So we can say this is iodide, not chloride. So this is iodide and iodide. Okay, so if we add the aqueous silver nitrate, chloride ion can produce the white precipitate, iodide ion, yellow precipitate, and bromide ion, green. So we will get the yellow precipitate. Now, to the third portion of the solution C, the student adds excess of aqueous sodium hydroxide. Now, aqueous sodium excess sodium hydroxide that can be used to test for the presence of uh, ammonium ion. So if we look at the presence of ammonium ion. So sodium hydroxide. Ammonia gas is produced on warming because we're not warming the mixture. So that's why some of the ammonia may be produced, but we will not get any observation, because we are using the excess of aqueous sodium hydroxide, and because we're not warming the mixture, so that's why there will be no change in color. The student warm, yes, here he is warming the mixture. So warm the product from the C1 and then test any gas produced. So here you can get the ammonia gas, so pungent smell gas. Ammonia is produced, which turns moist red litmus paper blue. Moist red litmus. So you can also collect the information from the qualitative analysis notes, as you can see that ammonia produced on warming. Then on the next page, we can see that the ammonia turns pink red litmus paper blue. So you can get information from these qualitative analysis notes. Now, on the next part, test on solid D uh, shows the tests and the student's observation on solid D. Number one, test one, do a flame test on solid D, a yellow colored flame. If you look at your flame tests, so you can see that the yellow flame mean Na positive. So again, gently heat about half of the remaining solid D. Uh, hold a strip of the anhydrous cobalt 2 chloride paper at the mouth of the boiling tube. Steam is given off. Steam is given off and condenses from at the top of the boiling tube, and there is a condensation. So the anhydrous cobalt 2 chloride paper change color. This anhydrous cobalt 2 chloride paper is used to test the presence of water. To test the water, we can use anhydrous cobalt 2 chloride, two reagents, anhydrous copper 2 sulfate or anhydrous cobalt 2 chloride, they are used. So anhydrous copper 2 sulfate changes the color from white to blue, and this will change the color from blue to pink. This will change the color from blue to pink. So this is the test for water. It means that this substance may be the hydrated compound, which contains water of crystallization. So dissolve the remaining solid D and the water to form solution D. Divide solution D into three portions. To the first portion of the solid solution D, add aqueous ammonia dropwise until in excess, so green precipitate. So just look at the qualitative analysis notes. Aqueous ammonia, green precipitate. Okay, so these are the tests. Now chromium, Cl3 positive, so aqueous ammonia with green precipitate insoluble in excess. Iron 2, aqueous ammonia with green precipitate insoluble in excess. So if we are getting the green precipitate, it means that this solution may contain iron 2 and chromium 3 as well. We're getting the green precipitate by adding aqueous solution of sodium hydroxide, so it may contains iron 2 or chromium 3. The second portion of the solution D, add a piece of aluminium foil and about 5 centimeter cube of aqueous solution of sodium hydroxide. Then green precipitate. Heat the mixture formed and hold damp red litmus paper at the mouth of the boiling tube. The red litmus paper remains red. Okay, then test 5 to the third portion of the solution D, add about 5 centimeter cube of dilute nitric acid and bubbles of the any gas formed through lime water. And the lime water turns milky. Now this is the test for carbonate, and that carbonate will produce the effervescence of carbon dioxide. State the final color of the cobalt to chloride paper in test 2. So cobalt 2 chloride paper that is used to test the presence of water, and the color changes from blue to pink. So the final color is pink. So we can write that the final color is pink. State over time the observation in test 4 shows is not present for 4. Now we're getting the green precipitate and the red litmus paper remains red. Basically, these reagents are used to test the presence of nitrate, that aluminium or sodium hydroxide. We can check in qualitative analysis notes as well. That This is nitrate. So add aqueous solution of sodium hydroxide and aluminium foil, ammonia produce. If there is ammonia can change the color of the litmus paper, that it turns moist red litmus paper blue. So we are adding a piece of aluminium foil and then aqueous solution of sodium hydroxide. Aqueous solution of sodium hydroxide can also be used to test the presence of cation as well, because this mixture contains some amount of Fe2 positive and Cr3 positive. So that will give us the green precipitate, but it will give a negative test of nitrate because aluminium foil, then sodium hydroxide, and if the ammonia is there, so ammonia turns the moist red litmus paper blue. If that remains red, it means that no nitrates are present, so nitrate are absent. So this will give a negative test for nitrate ions. Identify the gas produced in the test 5. Test 5, effervescence of carbon dioxide. So this is carbon dioxide. Identify the 3 ions in solid D. I've already explained that yellow flame test for Na positive, a green precipitate with sodium hydroxide, either of CFe2 positive or chromium 3 positive, and then effervescence with dilute nitric acid or hydrochloric acid, carbonate. So these are the 3 cations which are present, and 3 ions mean 3 cations and 1 anion. Then this is the last question of this paper. This is the question for designing experiment. So when excess dilute sulfuric acid, this is sulfuric acid, is added to the solid zinc, hydrogen gas, and the aqueous zinc sulfate are produced. So we are getting the hydrogen gas. Plan an experiment to show that copper is a catalyst for this reaction. You then should include how the results of the experiment will show that the copper is a catalyst for the reaction. And we are provided with the zinc powder, dilute sulfuric acid, copper powder, and commonly laboratory apparatus as well. So this reaction is between zinc and sulfuric acid. So first of all, if you want to make the fair test, we must use the fixed mass of the zinc because this is solid. So we have to use the fixed mass of this. And this is the aqueous solution and the fixed volume of uh, dilute sulfuric acid. So this is the first point, that add a fixed mass of zinc and fixed volume of dilute sulfuric acid. Normally, if we use the fixed mass of uh, dilute sulfuric acid, the volume should be in centimeter cube and the mass should be in grams. So this is the first thing. Then, if we mix these two reagents, hydrogen gas will be produced. So the next point is that measure the volume of hydrogen gas by using a gas range. Here, to measure the mass, you can use the balance, and for volume, you can use the pipette or burette. Then, so if we measure the volume of the hydrogen gas in the gas range, then until there's no fizzing, no effervescence or no fizzing, because in that case, the reaction must be completed. Now, if we repeat experiment by adding a fixed mass of zinc and copper, now add or repeat experiment by adding fixed masses of zinc and copper. So this was the experiment which was done without catalyst. Now we're using the catalyst, copper, then filter the mixture to get the copper. Now filter the mixture to get copper on the filter paper. Then measure the mass. Now, if the mass of the copper is constant, then we can say that it is used as a catalyst. And we can also say that we will get the same volume of hydrogen with or without catalyst. But in the presence of catalyst, the hydrogen is collected in less time. The same volume is collected in less time. So this is regarding the experimental designing. But if you want to solve the test for cation and anion, so don't forget to use the last pages of this paper, because they all contain the information about flame test, test for gases, test for anions, test for cations, and some observations of the every test is also there. Thank you.